For question number 10, we have this sulfur trifluoride anion. So draw the Lewis structure, then determine the hybridization of the central atom. This one's a little bit tricky compared to the previous one. So we've got sulfur trifluoride. So we've got our central atom. We'll set that as sulfur, and I need 3 fluorines surrounding. So I'm going to have 3 bonds off of that central atom. And the surrounding atoms are fluorines. So I'm going to pick my fluorine here. Fluorine and fluorine. So next we need to figure out how many electrons we have to assign. So sulfur comes with 6 electrons. Fluorine comes with 7 electrons. So I've got 3 fluorines times 7 is 21, plus the 6 from sulfur, right, is 27. And then the negative charge means I have to add in 1 more electron. So that's 28 electrons total I need to assign. Right now I have 6, right? I have 1, 2, 3, 4, 5, 6. So 28 minus 6, 22 electrons I have left to assign. So let's fill the outer shell of the fluorines. So I have 22 left. There's 6, right? There's 12. There's 18 of those 22. So that means I've got 4 electrons remaining that I have to assign. Well, I can't put them on fluorine because fluorine has a full octet. All 3 of those fluorines have a full octet. Sulfur only has 6. We've got 4 electrons remaining. So you might be thinking, well, that's breaking the octet rule. That is breaking the octet rule to assign those 4 remaining electrons on sulfur. But that's possible because sulfur has access to empty d orbitals. So I need to put 4 more electrons on sulfur. And that puts us in the 1, 2, 3, 4, 5 electron domain. So electron domain geometry of trigonal bipyramidal, and the molecular geometry of those 5 domains, 1, 2, 3, are bonding domains. So it would be T-shaped molecular geometry. Formal charges, 0, 0, and 0 for the fluorine. Sulfur is group 6, and it has 1, 2, 3, 4, 5, 6, 7 electrons assigned to it. So 6 minus 7, that -1 charge would be assigned, right, to that central sulfur. And we can see that here. There's 0 on fluorine, 0, 0, -1 on the sulfur. So now for our hybridization, I've got 1, 2, 3, 4, 5 domains. So to have 5 domains, I need 5 hybrid orbitals. To have 5 hybrid orbitals, I'd have to mix together 5 atomic orbitals. So that's 1 s orbital, 3 p orbitals, that's 4, and 1 d orbital. Blending those all together would give me 5 hybrid orbitals that would all be sp3d in hybridization. So the central sulfur would be sp3d. So that was a tricky question, and that we did have to assign quite a few extra electrons to that central sulfur. But once we did that, you should see 5 electron domains. 5 electron domains means sp3d hybridization on that central sulfur.